You know, when we think about AI, we picture it in the cloud, this weightless world of just code and pure information. But the truth? It's grounded in concrete, in copper, and in a relentless, hungry demand for power. Today, we're going to pull back that digital curtain and reveal AI's massive and often totally hidden physical footprint.
Look, we've all kind of bought into the myth, right? AI is this clean, virtual, almost magical thing. But the reality is brutally physical. It's built on immense power, on vast tracts of land, on millions of gallons of water, and on very real human labor. This isn't a story about software, folks. It's a story about heavy industry.
So what is this big physical secret? What are we really building when we say we're building artificial intelligence? Well, the answer just might change the way you see the world around you.
Let me just ask you this straight up. When you ask a chatbot a question, where does that request physically go? I mean, where does the thinking actually happen?
The answer, of course, is the data center. But we've got to stop seeing them as just simple warehouses for servers. They're not. They are energy concentration devices. They're the steel mills and the oil refineries of our time. And they're powering a whole new industrial revolution.
And that right there brings us to the single biggest physical limit on AI's growth. It's not a shortage of silicon or a lack of good software. Nope. It's raw, relentless power. The new oil is, quite literally, energy.
And you don't have to take my word for it. NVIDIA's CEO, Jensen Huang, he put it perfectly. The bottleneck for AI is no longer our imagination. It's our ability to plug the thing into the grid. The race for artificial intelligence has become a brutal, global race for electricity.
And that race is creating enormous challenges. Our electrical grid is fragile. It was never designed for this kind of insane load. And unlike our homes, data centers are relentless. Their demand for power never, ever dips. This is exactly why nuclear power is suddenly back on the table, not for some ideological reason, but for sheer baseload necessity. It's gotten so critical that entire AI projects are literally being shelved just because there's no power for them.
This energy crunch is redrawing the global map of power. Think about it. Countries that can't build and power these massive data centers won't be producing intelligence. They'll just be consuming it from others. This is a new, a subtle, and an incredibly profound form of dependency.
So, if energy is the fuel, where are the engines being built? Well, the answer lies in this quiet revolution that's happening in real estate, one that's being driven by land, by concrete, and by just massive amounts of capital.
For a century, what we could call urban gravity dictated real estate value. Being close to people in bustling cities and downtowns. That logic, it's broken. We've now entered an era of infrastructural gravity, where the real value is tied to power substations, fiber optic routes, and sources of cooling water. Value is migrating from where people are to where machines can be.
And OpenAI's Sam Altman just nails this strategic shift. He says this land is more than just property. He calls it sovereign territory for intelligence. Once you build a data center, it becomes this permanent strategic anchor for the future of computing. It's an almost irreversible fact on the ground.
This quiet shift has some very loud consequences. We're seeing our city centers get hollowed out, and it's not just because people left after the pandemic. It's because economic value itself has migrated. And that popular idea of converting all those empty office towers, well, a lot of the time, it's just a fantasy.
But who actually works inside these new sovereign territories? What about the human element? Let's take a look at the AI economy's often completely invisible workforce.
When you think of an AI job, you probably picture a software engineer in a sleek office, right? But the reality is, the electrician pulling high-voltage cable at 3 in the morning, the cooling technician responding to a critical overheat alarm, the security team patrolling the perimeter. These data centers are run by a highly skilled, physical workforce that has become almost invisible by design.
And this invisibility has created a really dangerous mismatch. So here's what's happened. First, we're automating cognitive, white-collar work at an incredible pace. Second, for decades, we have systematically devalued and underinvested in skilled traits. The result? A critical shortage of the very people we desperately need to build and maintain the physical infrastructure of the entire AI economy.
This quote from Mike Rowe just reframes the problem perfectly. He suggests we don't just have a labor shortage, we have a storytelling shortage. For 50 years, we told one single story about what success looks like, a 4-year degree and a desk job. And now, the world that story described is changing, and we desperately need a new one that honors these essential physical skills.
Okay, this brings us to our final section, and this is where the stakes get even higher.
We've seen the physical demands of AI. Now let's explore the risks and the really profound questions it raises about our own purpose.
This slide captures the central paradox of data centers. On one hand, they are our most important strategic assets, central to everything from the economy to national security. But on the other hand, because they concentrate so much in one physical place, they are also incredibly soft targets. They represent the most dangerous single points of failure in our modern society.
The danger isn't just your favorite website going offline for an hour. No, the real threat here is cascading failure. A successful disruption to a key data center could ripple outwards, taking down emergency services, financial markets, healthcare systems, all of it. The hidden dependencies are, well, they're truly terrifying.
And this all leads to a much bigger question, one that goes way beyond physical security. Are we, as a society, even remotely prepared for the consequences when not just data, but intelligence and decision-making themselves become this centralized? This is the social reckoning we're facing. The risk of a new class divide, but not of wealth, of relevance. The risk of what some people are calling underemployment of meaning, where you get a paycheck, but it doesn't give you any sense of purpose. And history teaches us a very, very clear lesson. Masses of people who feel useless, they become dangerous.
In the end, maybe these data centers are just mirrors. They reflect back to us what our society truly values at this exact moment in history. So the question becomes, what do you see in that reflection? Do you see speed over meaning, scale over dignity, efficiency over empathy?
And this leaves us with a final, powerful thought from the scholar Vaclav Smil. Progress isn't just about speed, it's about durability. As we race to build this new intelligent world, we have to ask ourselves, are we building something that will last, something that truly serves humanity, or are we just building it fast? The answer to that is going to define our future.